In this video, we're going to begin to look at the energetics of making a solution, and we're going to start with just some observations. So when you dissolve some compounds, such as NaOH in water, you get a hot container. While other compounds, such as NH4NO3, when it dissolves in water, you get a cold container. And so why is this? So that is the question we're going to start to answer in this video. So how do we make a solution energy-wise? And this is talking about the enthalpy of solution. So the first thing we need to do to make a solution is to break apart all the attractive forces among the solute particles. Since we are breaking apart bonds, we are breaking interactions, we have to put energy into that process to break apart stuff. Therefore, the enthalpy of the solute, delta H solute, is always endothermic, always positive. We also have to break apart some solute interactions because we are dropping, or some solvent interactions because we are dropping a solute into the solvent. Solvent has to make space for this to happen, so some solvent interactions have to be broken as well. So delta H solvent is also endothermic. But when we mix a solute and a solvent together, we will get new interactions. These new interactions release energy, and so this is exothermic. Delta H mixing is exothermic. So keep these things in mind. If you are breaking interactions, it is endothermic. You need to put in energy. If you're forming interactions, you get energy out of the system. You're lowering the potential energy of the system. So that's negative, that's exothermic. So the overall enthalpy change for making a solution, which we call delta H solution, is the amount of energy you need to put in to break apart the solute, plus the amount of energy you have to put in to break apart the solvent, in the amount of energy you get out by mixing the solute and the solvent. Alright, so step one, here's the visualizations of what I just talked about. Step one, you break apart all the interactions of your solute molecule except covalent bonds. Keep in mind, we are never breaking covalent bonds when making a solution. Only non-covalent interactions. So to make this breaking happen, you put energy in. Next part, we have to make space to put our solute molecules into the solvent. So to make that space in the solvent, we put in energy, so delta H solvent is also positive. Then we mix our solute and our solvent together. We form new non-covalent interactions, so delta H mix is negative, forming new interactions. All right. And so let's take a look at this whole process. So here is what we just talked over again. So our first step, and this is energy. You can think of energy being on this axis. The first step, we separate the solute. That takes energy. Our energy is rising. We separate the solvent. Our energy is rising. Then we mix our solute and our solvent together. If our energy is higher than what we started out at, we have a net endothermic process. That is, energy needs to be taken from the surroundings for this reaction to happen. And if energy is being taken in from the surroundings, our solution feels cold. While the opposite is, after we separate the solutes, we separate the solvent, we mix the solute and the solvent together. If more energy is given out than we have to put in, then this is a net exothermic process. Energy is being released from the solution, and then our solution feels warm. And that's it for the energetics of solution. So I will see you in the next video.